Hey everyone, it's Mr. Nicholson again. This week we're on more algebraic techniques for limits. But first, I want to give a quick shout out to David Lance, a good friend of mine. Graduated high school with him, and he currently works for NASA down in Houston, but he's also the owner of True Anomaly. So thanks for the hat. And anyways, let's get started. So our first limit example today. We're looking at the limit of this equation as x is approaching -4. So if you think about last week, what we had to do last week was one strategy was just plug in the value that we're looking for the limit, so -4. And direct substitution will not work here. If you look at -4 in this equation, it gives our denominator, the denominator becomes 0, right? So we all know what happens when divide by 0, bad things happen, right? Black holes are created, things just go completely awry. So we don't want to do that. But lucky for us, we don't need to know the value at exactly -4. We want to know what value it could be theoretically as we approached 4. Remember that soccer example where the video was buffering at a certain time? We didn't need to see exactly where the ball was at the time, but we looked at where it was before and after. So in these examples, though, the first thing we need to do is we need to factor any of these polynomials. So in this case, our numerator could be factored, and the two factors here will say, let's see, well, it's x squared. So we've got two factors. We also notice the negative sign here. It means we have an x plus a number and x minus a number. Right? So the minus means we have opposite signs. Two factors that multiply to 8, but add to 4 or subtract to 4. And let's see, well, 4 and 2 could get us to 2. So we want that 2 to be positive. So I'm going to give the 4 the positive and the 2 the negative. Then I'm going to put our x plus 4 here. So x squared minus 2x plus 4x gives us plus 2x and -8. So we're good. Same exact equation, right? If we were to look at this on Desmos, here it is. I'm going to turn the graph on, and there it is. So here what we really have is just a straight line equation, right? We've got, let's see, we're looking for -4 as we approach -4, because here at -4 exactly, it's undefined. Here's our hole, right? But we do find that as we approached it, we were kind of coming at it in almost -6, and then it just disappeared. And then the same thing here, as we approached it from the right, we were also approaching -6. So graphically, we're saying, hopefully our numbers come out and we get our limit to be -6. Another way to look at this, we could say, well, x plus 4 on top reduces x plus 4 on bottom, right? You're dividing by the same thing. So you could really kind of look at this graph and say that we're looking at the limit of just x minus 2. So let's try that. Let's try limit as x approaches -4 of just x minus 2. Well, if we do that and we use last week's direct substitution, we now no longer have a denominator of 0. What we have is -4 minus 2, or -6. So that's the best way to approach it. Now, can we just say that this graph of x squared 2x minus 8 over x plus 4 is the same graph as just x minus 2? Absolutely not, because if I graph just x minus 2, if I do that, and I say, oh, what's x minus 2 look like? Well, what that does, if we turn this off, if we follow this graph, and we go to -4, if I can get there, we don't have a hole anymore. So it is not technically the same graph. But for finding limits, the purposes of what we're doing here today, we can count that. So that's how I would approach this problem. We could have also, I know in the notes we talked briefly about how finding vertical asymptotes versus finding holes. And in your notes, you should have noted that you would have a hole if you have a factor in the denominator that produces 0, so x minus 4. But in addition, that factor is reduced by a factor in the numerator. So here's our x plus 4 canceling the x plus 4. And, well, not canceling, it's reducing it to 1. But yeah, that is our definition of a hole. So we would have our hole at -4. But both graphically through Desmos, graphically through Desmos, as well as using that idea of switching the equation to just be x minus 2, we find that our limit is, now I should say, let's do this. Because that's the question at hand was not finding the limit of x minus 2. The question at hand is finding the limit as x approaches -4. There. That would be your final answer. The limit of that original function as x approaches -4 is -6. So there you go. That's example 1. I'll have videos for examples 2 and 3, or A, B, and C here shortly.